The U.S. has been testing new secret hypersonic aircraft to prepare for Russia. Governments all over the world are developing these hypersonic aircraft in an effort to outdo one another in the never-ending power struggle between countries like the United States, Russia, China, and others. Stay till the end of this video to discover some of these hypersonic aircraft and decide for yourself which of them comes out on top. While a supersonic aircraft is one that flies faster than Mach 1 or the speed of sound, a hypersonic aircraft is a plane capable of flying at Mach 5 or 5 times the speed of sound. The speed of sound is around 760 miles per hour at sea level atmospheric pressure and air temperatures of 59 degrees Fahrenheit, 15 degrees Celsius, 1,225 kph. Hypersonic flight has been possible since the late 1950s, but designers will have to overcome some of the physical obstacles connected with ultra-high-speed flying before it can become practical. The first hypersonic aircraft we're going to look at today is the X-15. The X-15 was based on a concept study for a hypersonic research aircraft by Walter Dornberger for the National Advisory Committee for Aeronautics, NACA. The airframe RFP was released on December 30th, 1954, and the rocket engine RFP was released on February 4th, 1955. The X-15 was developed by two companies, North American Aviation and Reaction Motors. North American Aviation completed the airframe in November 1955, while Reaction Motors built the engines in 1956. The X-15, like many other X-series planes, was meant to be carried aloft and dropped from a B-52 mothership's wing. All X-15 flights were carried out by Air Force NB-52A, the high and mighty one, number 52-0003, and NB-52B, the Challenger, Series 52-0008, aka Balls 8 carrier planes. The X-15 was launched from NB-52A at a height of about 8.5 miles, 13.7 kilometers, and a speed of around 500 miles per hour, which is 805 kilometers per hour. The X-15 fuselage was long and cylindrical, with thick dorsal and ventral wedge fin stabilizers and rear fairings that flattened its look. Heat-resistant nickel alloy was used in parts of the fuselage. The outer skin, 9 Inconel X750. A nose wheel carriage and two rear skids made up the retractable landing gear. The pilot had to jettison the lower fin right before landing since the skids did not extend beyond the ventral fin. A parachute was used to recover the lower fin. If the X-15 program had continued, it may have served as a model for hypersonic flight on Earth as well as space flight. The initiative, however, came to an end due to a number of factors. One was a shift in leadership, with the National Aeronautics and Space Administration, NASA, taking over in 1958 from the National Aeronautics and Space Administration, NACA, NASA. After the surprise launch of the Sputnik satellite in 1958, another difference was the urgent political goal of beating the Soviets in the space race. In order to place the first man on the moon, U.S. policymakers chose rockets over the X-15 flight model. The physical limits of hypersonic flight also posed a barrier to the X-15. On October 3, 1967, pilot Peter Knight sped up to Mach 6.7, nearly igniting his craft's tail. 6 weeks later, on November 15th, pilot Mike Adams was killed in the third X-15's in-flight breakup. On October 24, 1968, the X-15 performed its final flight. By the time the X-15 stopped operation, the U.S. was already working on other hypersonic aircraft. One of such is the Lockheed SR-71 Blackbird. The Lockheed SR-71 Blackbird is a long-range, high-altitude Mach 3 plus strategic reconnaissance aircraft designed and constructed by Lockheed Corporation in the United States. The United States Air Force, USAF, and NASA both operated it. During the 1960s, Lockheed's Skunk Works division created the SR-71 as a black project based on the Lockheed A-12 reconnaissance aircraft. Many of the aircraft's revolutionary innovations were developed by American aerospace engineer Clarence Kelly Johnson. The SR-71 shape was inspired by the A-12, which was one of the first aircraft to use a decreased radar cross-section. Before the program was refocused entirely on reconnaissance, a bomber variant of the aircraft was under consideration. The SR-71 was longer and heavier than the A-12, allowing it to carry more fuel and have a two-seat cockpit. Mission equipment for the reconnaissance role included signals intelligence sensors, side-looking airborne radar, and a camera. The SR-71 was both longer and heavier than the A-12, allowing it to carry more fuel and have a two-seat cockpit. The SR-71 name is credited to USAF Chief of Staff General Curtis LeMay's lobbying efforts, as he favored the SR, Strategic Reconnaissance, designation over merely RS, Reconnaissance Strategic. In January 1966, the plane was put into service. The SR-71 flew at great speeds and altitudes during airborne surveillance missions. Mach 3.2 and 85,000 feet, 25,900 meters, allowing it to outrun or completely escape attacks. The typical evasive action in the event of a surface-to-air missile launch was to simply accelerate and outpace the missile. Due to the lengthy turnaround required after mission recovery, each SR-71 could only fly once a week on average. A total of 32 planes were produced, with 12 being lost in accidents and none being lost due to enemy action. The SR-71 was decommissioned by the U.S. Air Force in 1988, primarily for political reasons. Few were temporarily reactivated in the 1990s before being retired for the second time in 1998. The Blackbird was used by NASA until 1999, when it was retired. The SR-71's function has been filled by a combination of surveillance satellites and unmanned aerial vehicles, UAVs. Since its retirement, a potential UAV successor, the SR-72, is being developed by Lockheed Martin and is slated to fly in 2025. Blackbird and Habu are only two of the SR-71's nicknames. As of 2022, the SR-71 still retains the world record for the fastest air-breathing piloted aircraft, which it set in 1976. The previous record holder was the related Lockheed YF-12. Before we look at the last U.S. hypersonic aircraft today, be sure to subscribe to get more content like this. The last hypersonic aircraft we're going to talk about today is the Boeing X-51 Waverider. The Air Force Research Laboratory, AFRL, started the high-tech program for hypersonic propulsion in the 1990s. The AFRL awarded Pratt & Whitney a contract to build a hydrocarbon-fueled scramjet engine, which resulted in the SJX-61 engine. The SJX-61 engine was designed for NASA's X-43C spacecraft, which was subsequently scrapped. In late 2003, the engine was used in the AFRL's Scramjet Engine Demonstrator Program. On September 27, 2005, the Scramjet Flying Test Vehicle was given the designation X-51. The X-51 was carried to an altitude of roughly 50,000 feet, 15 kilometers, 9.5 miles by a B-52, and then released over the Pacific Ocean in a flight demonstrations. An MGM-140 ATA-CMS solid rocket booster propels the X-51 to a top speed of Mach 4.5, 3,000 miles per hour, 4,800 kilometers an hour. The rocket is subsequently discarded, and the vehicle's Pratt & Whitney Rocketdyne SJY-61 scramjet pushes it to near Mach 6, 4,000 miles per hour, 6,400 kilometers an hour, peak flight speed. The SJY-61 scramjet on the X-51 runs on JP-7 fuel and can carry 270 pounds, 120 kilograms on board. The U.S. Air Force announced in May 2013 that the X-51 technology would be applied to the high-speed strike weapon HSSW, a missile similar in size to the X-51. The HSSW was scheduled to take to the skies in 2020 and go into service in the mid-2020s. It was supposed to have a range of 500 to 600 nautical miles, fly at Mach 5 to 6, and fit within a B-2 bomber's internal bay. On its fourth test flight, the X-51 completed its first totally successful flight test on May 1, 2013. The X-51 and booster rocket separated from a B-52H and accelerated to Mach 4.8, 3,200 miles per hour, 5,100 kilometers an hour. It then ignited its own engine after separating clearly from the booster. The test aircraft then accelerated to Mach 5.1, 3,400 miles per hour, 5,400 kilometers an hour, and flew for 210 seconds until running out of fuel and plummeting into the Pacific Ocean near Point Mugu, totaling more than 6 minutes of flight time. Telemetry data was obtained for 370 seconds of flight. The test signaled the program's completion. The successful flight, according to the Air Force Research Laboratory, will serve as research for realistic hypersonic flight applications such as missiles, reconnaissance, transport, and an air-breathing first stage for a space system. What do you think about these aircraft? And which do you think is the best? Let us know in the comments section. While you're here, be sure to watch our video on the Russian S-400 jet.